Okay, so welcome back. This is part 3 in our series where we're giving you a very, very simple explanation and clear to understand description of control systems and how they work. And we're using a very intuitive and easy to understand model of you as a control system driving a motorcycle. And I encourage you to look at the first 2 parts in this series where we talk about the concepts and make it very easy to understand the basic concepts. And in this video, we're going to develop, based on those concepts, this simple simulator that is simulating you driving a motorcycle. And here you can see we started up and hit the throttle. And after 30 or so seconds, we've reached almost 120 miles an hour. So in this video, we're going to write the code to make this simulator. And we're going to use C#. You can use any programming language you want. But C# is nice because it's object-oriented. And as we mentioned before, we are modeling real-world objects like you as a controller and a motorcycle as the device being controlled. So in the previous 2 videos, we worked through an understanding of this system right here, which basically models you as a controller controlling the motorcycle. And I encourage you to look at how we did that. Pretty straightforward. We've got you taking in an error between what you want the speed to be and what it is, and putting that out as a fuel valve position into your motorcycle, which takes that fuel valve position and generates a speed of the motorcycle. So what we're going to do in this video is basically take that and make it into an object-oriented simulator. And that's one of the great things about object-oriented programming. We have real-world objects like you and the machine, the motorcycle, and object-oriented programming makes it so much easier to model this and simulate it. So, of course, we're going to have a time-based simulation. Every step in time, we're going to have to calculate this. And we're going to have these 2 primary objects, the machine that's being controlled and the controller, which is you. So you can see we've got 2 objects. We can use object-oriented programming. We're going to do a time-based simulation. And one of the great things about using, for example, you controlling a motorcycle, as we mentioned in the previous video, is there's a lot of data out there about how motorcycles work and how they respond. And we showed a speed versus time characteristic for an arbitrary Honda motorcycle. And so our goal in this video is to make a simulator and see if we can model this motorcycle and you as a controller to give a response that matches this curve that we got from this wonderful website called motostats.com. And here we showed that here's what we've got in the code that we're going to be working on, a very close, without doing a lot of tweaking, a very close simulation showing that, you know, the motorcycle gets up to around 110 miles an hour after 30 or so seconds. It's really good to have something like a motorcycle as the thing we're modeling because there's a lot of data out there that we can use to verify our code. What we're going to do in this code is we are going to model those 2 objects, but we're also going to add a 3rd object. And that's going to allow us in the future to expand our model to model more than just you and a machine, but model maybe many machines that are being controlled. And what we're going to do is add one more object as a class, and it's going to be called SCADA. And SCADA in the real world is extremely widespread and used everywhere. It stands for Supervisory Control and Data Acquisition. And as you can imagine from the title, it provides some overall control. Like if you have many machines on a system, like your power system or a large factory, you've got a bunch of machines, and you want to control them all simultaneously using different logic than just you deciding what the speed of the machine should be. The SCADA system is used all over the world to gather data, which is the data acquisition, and then turn that data into controls that provide, in this case, like the reference or what we want the speed of the machine to be based on not you, but on the SCADA system that's monitoring many machines. So we're going to add that as we're going to start out with a very simple class called SCADA. And we're just going to use it to hold some data. But the primary workers here are going to be the machine and the proportional controller, which is you. So now let's take a look at the simple C# solution that we're going to develop to make this simulator. Now here is my main Form 1. Again, this is C Sharp, Windows Forms application. And I assume you know how to set that up. I've done many videos showing the basics of how to set that up. We have basically our Form 1, our main form. And it's laid out the way I lay out all of my applications if I can. I've got documents, I've got to-do list, and then I've got my Form 1. I've got some initialization where you always initialize variables. I've got the main entry point, Form 1, and then I've got the event handlers and the methods. Pretty straightforward main form1.cs. So as I mentioned, we're going to add 3 more classes of objects to this application. And to do that, again, you just right-click on the project, add new item, and we're going to add a class. And the first class we're going to add is the SCADA class. And the SCADA class is very, very simple. All it does is it holds some data. Again, we can make this into a lot more later on, but it's just holding data that everybody can access. The next one is the controller. This is going to start out by simulating you and how you control your motorcycle. Again, we've got properties, we've got a constructor, and we've got methods. And the third class we're going to add is the machine class. It represents an engine which takes a throttle or gas pedal position as input, and its output is engine speed in miles per hour. We talked about that in the first 2 videos. Again, it's got properties, a constructor, and methods. So let's look at our main Form 1 and see how we do it. The designer for this, I'm going to assume you know how to do this. I've done this in many videos, how to do charts. Really, I've just got a track bar here that we're going to use to simulate you controlling the throttle of the motorcycle. We've got a chart that's going to show us in real time. We've got a bunch of labels that show us real time desired speed, actual speed, throttle position. And we've got proportional gain, which we talked about previously. It allows you to set, before you start the simulation, you can set the gain of your controller. And then we've got 3 buttons, a start button, a stop button, and an exit button. So I assume you know how to add those. The one other thing we've got is, of course, the system timer. And you can do that by just drag and dropping a timer into this onto this form. And then you can select it and you can set the values of that. We've got the interval set to 100 milliseconds, or 1/10 of a second, and the name is timer 1. All right. To get the event, of course, you double click on this. It will initiate event that you can do your calculations every 1/10 of a second. So Form 1, using system drawing, so we can set colors with system Windows Forms, and then data visualization charting. Again, I've done videos on charts, so that should give you all you need to know. Documentation to do. But first we're going to look at the initialize for this main application. So first we're going to configure the engine internal properties. We're going to set the max speed equals to 120 miles an hour. Just arbitrary, I'm just going to choose 120 because, as we saw in the real world chart for the Honda motorcycle, it gets up to about 110, 120. Maximum throttle position is 1. Minimum throttle position is 0. And as we talked about, we need a miles per hour to throttle ratio for the controller. It takes in a miles per hour error, and it's got to convert that to a throttle ratio. And we're going to use this engine maximum speed, which is 120, over the maximum throttle, which is 1. All right. Configure the human controller internal properties. The proportional gain is 1. We talked about that before. We also have 2 properties we're not going to use yet. We'll use in the future: integral gain and then derivative gain. We're going to set those to 0. And then the real-time control parameters. Desired speed, 0. And we're going to adjust that based on the real-time throttle. And then real-time throttle position is 0. We're just initializing those. And here we are going to instantiate our 2 models. Our engine, which is a new machine. We've got our machine class we'll talk about. And controller is person for our new controller. And we will give it these values. So for the machine, you can see we've got the internal properties. We will pass it the engine maximum speed, the minimum throttle, and the engine maximum throttle. All right. And then for the person, the controller, we'll give it the proportional gain, which is 1, integral and derivative, which are 0 for now, MPH to throttle ratio, which we calculated up here, engine minimum throttle, and then engine maximum throttle, because you're going to need that information about the machine, the motorcycle, in order to do its controlling. So we're passing all that data and instantiating those objects. All right. So now that we've got all the initialization done, we'll go into Form 1, and we have the standard initialized component, and then we have to set the time step seconds for our SCADA class, which is going to maintain the total time step in seconds. And it's going to be the timer 1 interval, which we said is 100 times 0.001, which gives it to us in seconds. So it's going to be 0.1, because this timer interval is in 100 milliseconds. So we're going to store in our SCADA class that time step in seconds. It's going to maintain that so everybody can grab it. It's public static double. And then we're going to say, we're going to use our track bar maximum, and we're going to use the engine maximum speed as the maximum. And we're going to convert to int32, because the track bar works on integers. And then proportional gain text, we're going to say 1.0, and the proportional gain back color is yellow. That's for, allows us, before we start, we can set the proportional gain. So that's basically it for running the main form. And then it's going to be controlled by the event handler, the time step in milliseconds. We have 4 events that we have to capture and use. The first one is the important one, the timer 1 tick. So every 1/10 of a second, that's going to recalculate the state of the controller in the machine. We also have an event for the button start, the button stop, and the button exit. So the button start, we're going to just enable the timer. Timer enabled equals true. We're going to set the proportional gain text to text proportional gain dot text, and then person proportional gain, we're going to convert to double the proportional gain text, and then the text proportional gain back color, we're going to say color equals white. So it starts out where this is yellow, and then we put in our value and we hit start, and then it converts that value into a number that we can use for the proportional gain. So it sets that to the person proportional gain, and so you can do your simulation. So that's all it does with our button start. Button stop, it just disables the timer when you want it to stop. And then button exit, application exit. Very straightforward. So the real workhorse here, as in most of the engineering applications, is this timer. Okay, so with the timer 1 tick, the event handler for the 1/10 of a second timer tick, pretty straightforward. First, we have to update the sample time based on the existing sample time plus the time step. So we're incrementing the time, the sample time. Then we have to, in real time, figure out what's the desired speed from the track bar. The user in real time changes the track bar. So we take that value, convert to double, and that's the desired speed in miles per hour. Then we have to feed that into our main controller, our person controller, and it will do that conversion from miles per hour to throttle position and return a throttle position, all right? So we know what our desired speed is. We feed that into the person's brain, and it returns a throttle position. It twists its hand based on what it thinks the throttle position should be. Then we're going to feed that throttle position, and all the engine knows is, hey, whatever the input throttle position is, it tells me how much fuel is coming in. I can go through and I can tell you what the speed is based on that throttle position. So we're going to look at our person controller and our engine classes to see how these work, but we talked about it before. It's really pretty straightforward. Also, I've commented out this, which will give us the ability to figure out a certain time in the simulation, we can apply what's called a disturbance. So for example, if the machine is a motorcycle running along the highway and suddenly it goes uphill, suddenly the speed is going to drop. So here we can simulate that speed drop from external factors and see how the control system responds. But we're commenting that out for now. And then the rest of this is just updating the label text for the throttle position, the desired speed, and the actual speed. And then we're doing the chart. We're adding the engine miles per hour and throttle position, and we're just feeding those with the sample time in second. Again, I've done many charts videos, so if you don't know how to do that, look at those. But it's pretty straightforward. And then we are updating the miles per hour that we calculated and feeding that to the SCADA, which kind of maintains those values so everybody can access them. So that's it. The rest of the work is now done by the classes. So I think we'll wait till the next video. This is already too long for most people. So in the next video, we'll look at the SCADA class, the controller class, and the machine class and go into the details of how they work. So anyway, if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.